Hey, this is Carl Franklin.
And this is Richard Campbell.
And before we start the show, we'd like to bring your attention to some cool conferences we're going to be at in Europe.
Specifically, NDC happening June 12th through the 16th in Oslo, Norway.
All the usual suspects will be there. Hey, and they even let us in.
But don't hold that against them.
No. Well, this is their big show, Richard, the original NDC.
Yeah, which we've been going to for like 8 years.
That's right.
We don't know exactly what we'll be doing yet, but you can expect a great panel discussion.
Yeah, and of course, we'll be in the fishbowl making some great .NET Rocks shows for your listening pleasure.
So go to ndcoslo.com and register now.
And for more great NDC conferences, go to ndcconferences.com. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're here for an hour of Azure goodness. Yochay Kiriaty's here. We're going to be talking to him in just a minute. But first, Mr. Campbell.
Yes, sir.
How are you, sir?
I am doing well. You know, the allergy season is passing, and I've been slowly automating that place on the coast that we picked up last summer. I put a weather station in with this like 170-degree camera in it. It's made by a company called Bloom Sky, and it makes daytime time lapses of the weather for me.
Oh, nice.
So I watch the tide go in and out a couple of times, and you see the clouds rolling overhead, and the sun goes across the sky. It just reminds me every time I'm not there that I should be there.
Right, and do you like put this on your desktop or something so that you see
along with my little tide meter that always tells me where the tide is in that area too.
Very
so
cool,
I'm tormenting myself. That's what I'm doing, Carl. I'm tormenting myself.
That's right.
Thanks for asking.
Yeah. All right. Well, now that you've tormented yourself, I'll torment the listeners with a thing we call Better Know a Framework. Roll the music.
I don't know if that's actually a torment. Everybody loves that music. Especially the people in Manchester.
Yeah, that's true. They actually sang it.
Don't give away the secrets.
Right.
All right, buddy, what do you got?
So what I've got is something that I hadn't seen before, but I ran across it just, spelunking around Bing, and I happened to find a whole repository of Azure code samples. And I can't believe we haven't talked about this on the show before, but so this is show 1443. So if you go to 1443.pwop.me, you'll see these Azure code samples, and there are a lot of them there. You can search, of course. You can restrict it by platform. And there's all sorts of things from, Service Fabric and functions and media services. And one that pops up right on the front page today is C# Azure function for reacting to Azure Insights events. How cool is that?
That is pretty nifty. Yeah.
Yep.
It just save you some time, right? Before you start coding, go check the samples.
Exactly. And I find it really frustrating when you go to write, a little tool that just does something like that, like reacting to Azure Insights events or moving files from a blob storage folder to maybe some other cloud platform or something. So you got a couple APIs to juggle. And, the help content is out of date by a version. And, you're looking at the API and the methods and functions don't line up. And there isn't any real sample that's up to date, right? It just drives me crazy. And now you have to go spelunking and try to find how it works in REST and then how that might apply to your API. And, usually you're guessing and testing stuff and going to Stack Overflow. And it's not a fun thing. It raises your cortisol level, which is not good for you,
Getting sensitive about those hormones now, are you, my friend?
Yeah, or am I just describing development in general? Maybe I am.
Hey, being the networking geek, I immediately selected the product load balancer and got samples for configuring and controlling load balancers in Azure for Go, Node.js, and Python.
That's so cool.
That's cool.
Yeah.
Good find.
So there you go. Azure code samples. Know them, learn them, love them. And who's talking to us today, Richard?
Grabbed a comment off of show 1431, the one we did with Joe Audette, talking about Cloud Scribe and multi-tenant apps. Mm-hmm. And you remember the timing on the show? This is the one you and I did together in the studio.
Right.
This is when we were traveling around and stuff, and we'd just gotten back from NDC London, and I'd been working on the multi-tenant problem for already. So this was hugely relevant to the stuff I was doing. But Eckhard actually made a comment here, and I don't know if his name's actually Eckhard, because there are, folks named Eckhard. There's also a minor planet named 694 Eckhard.
Wow.
But I don't know if that's relevant to anybody. It's 100 kilometers across. If it ever hits the Earth, it's going to suck.
That's not Justin Kerbal?
Nope, not Justin Kerbal. That's a real. It's orbiting like 3 AUs out from the sun. But Anyway, Eckhard said, "This is very sweet. I just realized how horrid the multi-tenancy is, and I come from a WPF Xamarin background that did prepare me. So you're a godsend. I managed a team where the solution needs to have a new database for every client, and it's horrible. So the work in this space up front will pay itself many times over, or even if it's just a glint in your eye. You also missed a good scenario to consider even for an in-house line of business app, the parallel test tenant and the live business over one code and database makes life way easier. And this is a really cool idea that if you just start down the multi-tenancy path, then you just have a toggle to use test data versus production data. It may only be 2 tenants, but it's still better for testing and deployment in-house to not have to accidentally mix up test data with your production system. And who hasn't done that?
True.
Yeah. So I thought, very insightful, Eckhard. I appreciate your thinking on that all apps actually are multi-tenant apps when you just look at the test data alone.
Sure. So
thank you, Eckhard. A .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. Ba-dum-bum.
Send us a tweet. We name our minor planets after them.
Yeah, that's good. All right, let's bring Yochay on here. Yochay Kiriaty is a principal program manager at the Microsoft Azure team, specifically driving web, mobile, API, and functions experiences as part of Azure App Service Platform. Yochay has been working with web technologies since the late 90s and has a strange passion for scale and performance. An unnatural passion, we might say.
Somewhat.
You can contact Yochay at yochay@microsoft.com. That's YOCHAI. And follow him on Twitter at YochayK. Welcome, Yochay.
Thank you.
So we were sort of geeking out a little bit before the record button got pressed about, how long we've been doing this stuff. And, web technology since the late 90s, that's pretty much when it all started. I mean, for the majority of people, 94, 95, that's when we started taking note of it.
That's where we started taking note of it, and it was, you guys were mentioning how painful it is today to look at documentation that is obsolete.
Yeah.
And back then we didn't have Git, right, or anything, or any of the sample or anything online. It was wasn't even proper HTML at that time. So it was interesting and challenging at the same time building web technologies.
Yeah, and even in the 2000s, it was challenging before we had NuGet and Git and GitHub and all of that stuff. Those things really just made it so much easier. Yeah,
the whole idea of social and open source, basically, that's the thing that eventually made a big drive and jump in towards of pushing in technology adoption. That was the main big driver in my mind that altered the course of history, or just the web.
Yeah. So really interested in diving into Azure Functions here. As I was mentioning on that samples page, there was one that just stuck out about App Insights. Just one of the millions of things that you can do with a serverless function. And I find myself having to write these a lot. These just little, we used to call them daemons, things that run in the background. They take some input and they spit out some output, and, they could be integrating several APIs together. And, these are the kind of things we used to just run on a machine somewhere in the office until it didn't run anymore. And or if it needed to scale up, good luck with that. So.
Yeah, pretty much. So Cloud Glue or Cloud Scripting, whatever you want to call that, whatever nickname you want to attribute to those scenarios, is a very, very common scenarios. in a common scenario. And with respect to Azure Functions or serverless or Logic App and or serverless combined, basically serverless as a solution for those kind of problem is ideal because it's exactly that. You don't need to set up that server underneath your desk or anywhere else or a VM in the cloud today. You just write a function that reacts to whatever events that you want to act, or write a logic app that can combine together, and you have the capability to run, and inherently the system will take care of scale and security and everything for you as you need to. That's where the power of the platform comes. But here, the developer don't really need to think about anything other than just, hey, what is the event that I'm consuming, and what business logic I want to apply to it. Whether it's event, App Insight integration, VM restart somewhere, or anything else that happens. If you have a trigger, if you can webhook it or any other means of triggering it, then you're off to the races.
Do you really see Azure Functions as just glue, or do you end up using nothing but functions, like as a migration path?
So that's a great question, and I think the answer is there's no straight answer. Obviously, there's no one answer to rule them all. Mm-hmm. Everything you ask can be answered with a depend. Yeah. But specifically, we see a lot of the adoption pattern we often see is companies, small, big, large, enterprise. I mean, it doesn't really matter. It mostly depends on the project. Most are existing projects, and in terms of volumes. And basically what you see is people, tipping their toes, trying, hey, I have an event, what can I do? I need to monitor, as you said. Like, I have a system already, it uses App Insight, I have an event now, what do? I write another system, then who's going to watch the watcher, right?
Right. Do I have to, I know what I don't want to do, I don't want to light another VM up.
Correct. So basically you have an event coming from, let's say, App Insights, errors, threshold is passed, CPU is too high, your VM is restarted for whatever reason, right? Whatever alert you're handling, it's a webhook. Now you have a function, you can secure it properly with keys, certs, whatever you want, AD, and now all you need to do is just write the business logic you want to do, like, maybe I need to recycle an event, maybe I need to scale up, scale down, maybe I take another operation, whatever your business is, you can just write it, deploy it to the cloud, and voila, it just runs. So those are very common scenarios we see in terms of people starting, and when they see how easy it is, and that it's functional and working and save a lot of time and effort, slowly they venture into, hey, maybe we can do more, and then they're starting to re-architecting their applications, adding more and more. Specifically for .NET Azure users, existing Azure users, if you've been using App Service in the past, there's a good chance you've been using Azure Web Job SDK. Yep, Web Jobs have been a staple of mine for a long time. Correct. It's been a while. It's been out for a while. Yep. Over 3 years now in the Web Job SDK, and the Web Job is a feature almost 4 years. And I was one of the original PM on the Web Job feature itself, which was just exactly what you mentioned before. Hey, I want to run this cron job or this daemon basically in the background. I have an async task for my web front. And it's one of the most popular and used feature for App Service. And it's also basically the core runtime or core technology that Functions uses to basically run, because it's very inherently and very simple to what we have. Those kind of users tend to take their web job and port them very easily into Functions and so forth. So we see more and more companies coming through that path of adoption. And we do see the other two big scenarios that we have are IoT. It's very natural. Anything that with a stream go to Event Hub, Service Bus, any of those stream trigger that you have, it's very natural to plug in a function, because basically Functions will take care of the scale for you. Yeah. Inherently, those events, the stream that is coming, the work that you're doing is very respectively small. It's like, hey, here's a message, you do something to it, you move on. Either you move it down the pipe or distribute it to a different location. So those are very common as well.
Now, with web jobs, I noticed that there's an API that you have to pull in if you want to do some certain things. Are there any requirements to do an Azure function, or can I take just raw C#? Can I essentially just take what is essentially a console app. However, I need to change the entry point, but just put that in an Azure function with whatever, NuGet packages I need, and I'm off to the races? Or is there anything specific to Azure that I need to have running in there?
So the answer would be you should be able to take your code, and if you're copy pasting it, then you probably need to make minor modifications, how you use IO maybe and stuff like that.
Sure.
But dependencies are the same. You define your NuGet packages in project.json, get rehydrated automatically, and so forth. So all of this would work. On top of that, function supports batch today. So in theory, you can take your executable, put it create a batch file, and that will run your executable for you regularly. Does you will run any executable. Just make sure that those executable are not long-running tasks and so forth. Like they're not the listener itself for the event. They're just consuming the event.
You mentioned I/O. Does that mean that I can't have a folder and maybe copy some files into it? I have to use the storage mechanism?
No, you can definitely. An Azure function app, which holds all your function, is literally another Azure App Service application.
Okay.
So you can just deploy to root whatever you want.
Great.
Or any other folder, obviously, under root app data if it's .NET or any other place. Yep, it's just a regular web app in that nature. Yeah. You can definitely deploy whatever it needs to deploy with all dependencies of your application.
Yeah, I'm thinking of a serverless function that may download a log file from one system and then upload it to another system based on a particular whatever, So I have to have a temporary storage place to look at it and analyze it before I move it on.
Yeah, you have temporary storage. You have temporary local storage for each instance of the function that you run. So if you need to run multiple logs or there is a high volume, you can definitely you don't have to write to the shared location of all the function where the code is. You can write locally to the actual behind the scene. While it's serverless, it does run on a server. So you can write it to the local server disk as a temporary folder.
Now, is it normal practice to develop this in the Azure environment, or would I be building this code in Studio and then sending it up to Azure when I need to?
Yeah, that is really a good question, and one that we're not necessarily struggling. We had struggled in the past. I think we are clearly have a vision here. One of the key importance or the goals that we have set with Azure Function is to make it super easy to start.
Right.
So you log into the Azure, you create a new function app, takes about 30 seconds, click a button, I want to have an HTTP endpoint, so trigger, and that's it. Within, a minute or so, you have URL, you can copy paste to your browser, and it works. You can go into the portal and edit your code, whether it's C#, F#, Node. We are working on additional languages. We do support Python, for example, today, but it's in beta. So going back, you go to HTTP. You can add some NuGet dependencies. You can start using your code, write whatever you want to write, make HTTP calls, call to DocDB, call whatever other services, recreate logic, use put messages in a queue or anywhere else that will trigger further applications and so forth. So all this is very easy, and you can code a lot. And you can do a lot and achieve a lot with coding in the portal. But what we have found is definitely with the .NET crowd is that majority of us are just feel very comfortable in nature and at home, and we do Visual Studio work.
Right.
So we have Visual Studio. We have Azure Function tooling for Visual Studio. Works with 2015. It's still in beta. And it will be soon deprecated. We have made those announcements recently on a blog, on our team blog, and basically with 2017 and the new Azure Function tools, you'll basically be able to create precompiled assemblies. You can run locally and debug locally. You'll be able to create an assembly with multiple function, multiple entry points, so to say. You'll be able to attribute and annotate your function with respect to the triggers and the bindings. Azure Function has bindings, in and out bindings. So all this will feel very natural to any .NET developer working with Visual Studio. behind the scene, the tooling that we create in combination with the Visual Studio team will generate and create all the artifacts and whatever needs to happen. When you deploy it to the runtime, it will be a proper Azure function that will run for you.
Nice.
I want to do a deep dive into some of these features that you just rattled off, but before that, we have to pause here to pay the bills. This episode of .NET Rocks is made possible in part by Windows on the Google Cloud Platform.
You may not know this, but the Google Cloud Platform supports Windows Server 2008, 2012, and 2016.
It also supports SQL Server versions 2012, 2014, and 2016 standard, web, and enterprise editions with high availability.
You can deploy your ASP.NET Windows apps to Compute Engine or your ASP.NET Core apps to App Engine or Container Engine. That's Google's hosted Kubernetes environment.
.NET and .NET Core libraries are there for all 200 plus Google.com and cloud services in NuGet, led by John Skeet of Stack Overflow fame.
But what about Visual Studio integration? Oh, it's there. You can use Visual Studio to manage your GCP resources and deploy your existing apps.
You get stack driver logging, error reporting, and tracing support for .NET and .NET Core.
PowerShell commandlets for GCP, which run on Windows and Linux.
And a great set of partners to bring your Windows and .NET workloads to GCP, including Capgemini, Nudesic, and Magenic.
So go to gcp.netrocks.com and get your free trial today.
So Yochay, in that list of features that you just mentioned was remote debugging. So does that mean that in Visual Studio, I build my function, I deploy it to Azure, I set a breakpoint, I run it in Azure, and I get the breakpoint on my machine?
Yes, so the answer is yes, but there's small asterisks attached to that yes. To provide a complete answer, you can, obviously with Visual Studio, you would expect local debugging. An Azure function has a local runtime that you can deploy on your machine. Mm-hmm. Currently, it's working only for Windows, but we are doing the work to enable it to run on other OSs as well. That's hopefully by the summer time, give or take.
Okay.
And this will give you basically the ability to run the actual Azure function runtime locally.
Right.
Which just, in terms of running your function, it's literally the same code that runs in the cloud.
Okay.
The scale piece is not there. The thing that runs your multiple instances. When there's like a million events, then we make sure that you run a lot.
Sure.
But to test your business logic, you can do it locally. Azure functions run on top of Azure App Service. Azure App Service has had a feature called remote debugging since 2013,
yep,
which basically allows you to break in remotely literally on a functions or on code that runs in the cloud. You could do the same thing with Azure Functions. The small asterisk is that when you do that, basically your entire function app halts, because that's how the model works.
Right.
So no other triggers are being consumed across all your functions within a function app, because a function app could have many different functions in it. Therefore, if you have 2 HTTP triggers or whatever, 3-4 APIs with HTTP triggers, a couple of queue triggers, and a blob trigger, you break on one, you stop them all. When you scale out in terms of in function, you scale out or run on multiple instances much more frequently than you would run on a regular app service plan.
Yeah.
Because the nature of functions are basically ephemeral and short-lived, so we spread them around as we see fit, which makes it, again, harder to find the right instance that you're running for and so forth, and you're debugging only a single instance out of many. So while you can do remote debugging, and it is a really good demo to see and show, it does have its caveat, and you need to understand what's happening behind the scene and what you're doing. It's obviously last resort if something blows up and your system is down, then you would probably use that. For regular operations, I would heavily rely on telemetry. And you mentioned App Instant integration, which we have a great one built into the platform as a beta right now, which we announced a couple of weeks last week. Yeah. We're going to definitely keep hammering that piece as well, because functions and serverless in nature is basically asynchronous distributed application, and sometimes it's hard for folks to imagine and see the big picture. And proper telemetry and emphasize on DevOps operation with that in mind is super critical to the success of the whole serverless thing.
Yeah. Yeah. And you also mentioned webhooks is for triggers, webhook bindings, that kind of thing. Just like we can do now. And if you haven't played with that, that's a game changer.
Yeah, you basically set up a webhook, a public API endpoint, if you want to say, in like literally a couple of seconds.
Yeah.
Azure Function is a programming model, right? It's we don't want to call it a framework because it's big and heavy and baggage.
Sure.
Mm-hmm.
But it is a programming model, and you buy into it when you go into working with functions. And it saves you the requirement. I mean, App Service is a great Azure service. You still need to, which is a fully managed service. We manage all the VMs for you and the scale and all of that. You still need to build an app, whatever framework you're using, and deploy it.
Right.
With functions, you do need to deploy your code, your function, your business logic, but you don't need to have a framework and build and deploy the whole thing.
Yeah.
We'll change a little bit with the .NET definition, but it's still very light. And I think that's the big difference in terms of how people.
And that's Microsoft's way, isn't it? I mean, you guys strip away all the gunk that we don't want to have to deal with, and just let us focus on our code.
Yes. That's as I said, when we started Azure Functions a year and a half ago, almost 2 now, we were solely focused on what we call internally within the team 5 minutes to wow, basically.
Yeah.
So if you don't know Azure Function, you ever started, you just literally sign up for Azure and you click a button. We want you to get very successful very quickly, even if it's a simple scenario. And yes, that's what we do with Azure Function and Microsoft as a whole.
It seems to me webhooks, web jobs, so forth, is Azure Functions the superset? Like this covers all of those things?
With respect to what, webhooks or web API?
Yeah, well, we're talking about how we got stuff solved with webhooks and with the web jobs and so forth, and it just seems to me that Azure Functions is the broader concept.
Yeah, Azure Function you can think of basically, it's like a function as a service. We took the Chris Anderson, who works on Azure Function as well, and he is still the PM for WebJob. Basically says like, hey, we took the WebJob and we turn it into a service. So you can think about that basically. You took a framework and SDK and a capability, and basically you service it to the point where, hey, you don't need to manage the whole infrastructure around. Even if it's simple, you still don't need to do that. It's basically we just offer you those capabilities as a service. Nice.
So you get it comprehensively.
Here's another thing that we can throw into the mix, which is Service Fabric. So, Service Fabric is those knobs and sliders for managing microservices. And how does Service Fabric fit into Azure Functions? Can we manage them with Service Fabric?
So, Service Fabric is a great technology. It's a great technology. It offers a lot of. It's very feature rich. Emphasizing on, as you said, microservice. With Service Fabric, you can easily implement a microservice pattern. They have an SDK. They have their own way of doing that. You need to again buy into that, but it's a whole framework that you need to work and utilize, and then you need to deploy. Once you deploy, it's very similar to PaaS on the developer side when you actually use and consume the services. But underneath it runs today. Which is basically a point in time, it runs under Azure VM Scaleset, and you're still left with those artifacts that you're responsible of managing.
Yeah.
The nice thing about Azure Function is the Azure Function runtime, SDKs, template, the CLI, the portal, all of the dependencies of Azure Functions are basically open source. So the runtime itself is open source, and you can take the runtime and just deploy it anywhere you want, and it would work, because that's exactly what we're doing with the Visual Studio tools. We basically wrap the runtime in a CLI form that you can just run the host locally. And you can imagine you can run them on any VM, basically, on any platform, or will be running on any platform in any cloud. So there is no there is nothing precluding basically running Azure functions on top of Service Fabric and combining both of them together. And it's not a secret that both teams are actually working on something like that to try to spread Azure functions to more surface area within Azure, basically taking the programming model with the benefits that you're going to get with other services. So we think it's a very strong model. Obviously, there's a lot of dots to cross, a lot of T's to cross and I to dot, but we're working on providing that kind of a solution.
Functions just seem like a great entry point. It's a great place to start, and you can really go quite far. In fact, I'm imagining you can build a whole microservices system with functions and probably not have any, and still be able to sleep at night.
Yes. So in short, the answer is yes, because microservices in general, in my mind, it's a very overloaded term already.
Sure.
Yeah.
And we like to say it's a pattern. It's a way of doing things.
Yeah.
And as part of a way of doing things, you can do, whatever you want to do with the pattern itself. With Azure Functions, you can definitely get into the notion of microservices. We introduced about a month ago a feature called Azure Function Proxies, which is basically you can think of as a reverse proxy, layer 7 gateway, whatever you want to do, whatever you want to call it. But basically, you can create a facade. You can expose a surface of API as a facade to any implementation backend, and the implementation backend doesn't have to be the function that you're currently running. It could be a different function, and in fact, it could be any different backend URL that you want. And we allow you to do transformation on data coming in and out, on headers, authorization. There is a pretty rich environment or capabilities that come with Azure Functions, which allows you, if you think about it, to create an API. The implementation could be different function app, and then each of those function app basically it's a microservice, and you can see how we roll this idea and flow with it. The thing that is missing, and we are, again, as I said, working on that, is that there is no one thing to bind them all, or one thing to rule them all. If you have 4 function apps with 4 different microservices, and plus a 5th one to basically just have the facade, the proxying 4 of them in terms of the API, it's your responsibility to manage those 5 independently, and you need to deploy and manage the lifecycle of each one and so forth. So we let you do the pattern. We still need to do a lot more work to make it feel natural, and like, hey, here's a whole thing as one solution versus 5 individual discrete entities that you are aware that are representing a solution for you.
Hey, Richard.
Yeah, buddy.
Guess what time it is?
It must be that happy time again.
That's right. It's time to be a little more technologically sensitive by killing our function-killing function.
How sensitive is it really to kill?
Oh, we just want to be a little more sensitive,
It's okay. By killing.
Yeah, well, if you have a function out there that is essentially while true, open bracket, close bracket, sometimes that requires death. Yeah.
Well, while true die. Okay, great.
Not just while true, All right. Well, anyway, it's time to give away a D-Experience subscription to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries, and deliver elegant .NET solutions that address customer needs today, and leverage your existing knowledge to build next-generation, touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best without limits or compromise. Learn more and download your free 30-day trial at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner is Alistair Anderson.
Congratulations, Alistair.
Yes.
Golf clap for you, sir.
Golf clap for Alistair, who just won a D-Experience subscription from Developer Express. A big pile of awesome from them just for being a member of the fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors, and every December we give away a $5,000 technology shopping spree to one lucky member of the .NET Rocks fan club. But you have to sign up to win. And we also like to ask our guests, Yochay, if you had $5,000 to spend on technology today, what would you buy?
That is an interesting question. There's so many options, right?
There are.
Yes.
There are many, many options. I probably go with either improving my home theater audio systems.
Nice.
With some cool speakers and a new sub, or I would go for like a professional hoverboard.
Oh yeah.
Uh-oh.
You like that stuff?
Yeah, we have few of the regular hoverboard or simple. The one that explode, they used to tend to catch fire and explode.
Oh, yeah,
the hoverboards that don't actually hover, you mean? Those ones?
Those were hoverboard.boom.com.
Something like that, yeah. So we have quite a few of them at the office, which are quite fun running through the corridors.
Yeah.
We even had, and we put it on YouTube as well, adjusting constant with hoverboard. So that was very fun. So getting one that is like professional grade, can drive to the city like crazy should be a very interesting experience.
Yeah, that'd be great. I can't wait for them to hit mainstream, as it were.
Yep.
I saw a video of one that was just amazing recently. I think that's picking up where the jetpack left off in the 50s, right? Everybody thought we'd have jetpacks and we'd be flying around.
All over. Correct. Definitely.
Quite popular, I think it actually started in Seattle, was this little electric unicycle.
There is a unicycle, yeah. There is.
Yeah, no handles or anything. You literally stand on it, it self-balances, and you're off and running around. And they're small enough that you would actually like take them on the bus with you and stuff. So it's sort of like that last mile finish of your commute with these little electric unicycles. And they same sort of effect as those hoverboards, that you just look like you're floating.
Right.
Yep, they have a lot. Their wheel, the single unicycle wheel diameter is much bigger than the hoverboard, like 3 or 4 times. So it's much more stable. Can go through potholes. Can you go up and down curves and stuff like that? So it's pretty nice.
Do you have a link to a hoverboard that you're looking at?
I can share with you guys.
Yeah, let's share that with the listeners.
Yeah, we'll do.
Why not? It's one of those interesting areas, electric vehicles that are that last mile thing.
Yeah, there is. I mean, I don't know how it's the rest of the world, but in terms of Seattle, greater Seattle area, it's where I live. You can see a lot more electric cars. A lot. All versions, definitely, gazillion amount of hybrids, obviously, but you can see a lot of just electric cars. To the point where the legislator around here are actually thinking that in a very short future, they're not going to get enough revenue from taxes collected on gas. So they want to create a different tax for how much mileage you're driving, regardless of the engine that you're using.
That's definitely something that we're all talking about.
Yeah, Norway's got that problem in a big way, and they're talking about just taking away some of the perks to get people to switch to electric because it's unnecessary now. They're not perks. Like, try and find if they all have electric cars, then the special electric parking spaces, they're full.
Yeah.
Yep.
Yeah.
Definitely.
Jumping back into this just a bit. Once I've got an Azure function up and running, I mean, this is my test case. What happens in the multi-instance scenario? So if I get 5 requests to a function, does it light 5 instances, or is there some kind of sharing process? How is it multi-entry?
So yeah, it's definitely multi-entry. Mm-hmm. If you would think about it that way, and it's very much dependent on the trigger type that you have.
Right.
To be specific, HTTP are basically requests coming in, and someone needs to handle them rather quickly. So they'll be dispatched to the proper, go through Upservice, the front ends, and so forth, and they'll be dispatched to the relevant servers that are actually running your functions and handle them. Queue trigger, event triggers are also the same thing. If you have like 1,000 key messages on a queue, what will happen is we'll start collecting them, and we will spin up more instances of your function app that will basically run in parallel, plus the debatching that happens and the runtime for a single function by default is also parallel. So we are debatching, we are reading from the queue like 16 or 32 messages and running them in parallel on the same box.
Right.
So this happened. The way that Azure Functions scale is basically that the magic is that it's unlike regular autoscale, which usually translate to CPU and memory and VM characteristic.
Right.
And the reaction cycle takes a couple of minutes, basically. With Azure Functions, what happened is that we monitor your input triggers. We understand the velocity or the amount of input data triggers that your functions are getting. We know how much you are being able to basically dequeue or handle. And it's quite simple. If the vector of incoming request is higher than the vector of handling of the request, we just add more instances of your function.
Right.
To the point where you can handle enough or even decreasing that. And then we just let those functions die. If there's no more work, they will just simply naturally be removed from the system.
Well, I mean, doesn't a function effectively die once it's finished an execution path anyway? Like they're all stateless and immutable anyway?
One would hope, right? This is a recommendation that we have.
Unless you got that while true function I was talking about that never exits.
Yeah. So Azure Functions has two modes that you can run, which is quite unique to the platform. Again, because it's based on app service, you can run Azure Function in a regular app service plan, which basically means you're running a web job.
Yeah.
In kind of
You've made it into a web job,
but just a lot easier in terms of programming model, and as a developer, a lot more accessible to you. Yeah. You can also run in a consumption mode, and a consumption for Azure Function is basically that's the serverless piece. Is that you're not defining any server or anything like that. We will make sure that it works and run and scale as needed. Those has a lifetime runtime limit right now of 5 minutes, so your while true will work for 5 minutes, and then gracefully or not, be removed.
One way or the other, you're dying in 5 minutes.
We will gracefully remove you from memory, your function. The 5 minutes is mostly policy. It's something that we are looking into changing and so forth. But even so, we're not going to expire it to run as much as you want, due to the nature of how actually Azure Function runs behind the scene, which is maybe a topic for a different episode.
But it does beg the question, what do I do in the case of long-running tasks?
So it depends what is a long-running task. If you need raw compute power, I need to run this process on this, video, image, whatever you want. And I need to literally run the CPU for many, many minutes, hours. Then Azure Functions will not be able to serve you unless you're able to basically, and this is a recommendation that we drive a lot, if possible, take this huge chunk of work, find a way to shard it into smaller pieces, shove those into a queue, basically, hey, here's a queue message that points you to the right location in which the data is and what you need to do with it. If you can slice and dice enough time that you can run under 5 minutes, basically what will happen is all of those now will try to run at scale in parallel, if possible. So for problems that kind of algorithm works, because not everything can be solved that way.
That's true.
If you can do that, then Azure Function will actually yield a much better result in terms of performance, because let's say, a processing of an hour can be reduced literally to 5 to 10 minutes.
Just with a lot more compute consumed in those few minutes.
At the same time. Basically, it's the same. If you look at the area underneath the graph in terms of volume of CPU that you're using, probably going to be the same, whether it's an hour or 5 minutes.
But if you have something that is going to take, let's say, 50 minutes or an hour, you can just use an Azure service for that, right? Because is there not a time constraint on that?
So you can use an Azure service. We can't do it today, but we're going to be able to do it very shortly. You can still run a function on a regular app service plan. Today what happened is that unfortunately it's a design, but we basically will remove your function from memory, even if it's running, but if there's no activity, saying no triggers. But we are basically able to work around that, and then you can actually take your function, again, the programming model, as a trigger, as an event base, and then be able to run whatever algorithm you need. If you run a regular app service plan, you'll be able to run for, any amount of time that you want, basically.
Sure.
And if you think about the model where it's not a huge volume of compute, but it's like a bunch of these things are long running, you could build this with a set of Azure functions that call to these long running things that didn't have callbacks to other Azure functions to complete.
So yes, definitely you can do that. You can do if you're running on a this is the second type of long running. Let's say you need to run. It's not necessarily run a raw compute, but it could be what you related, like, hey, there's a business process that needs to finish on a different subsystem or whatever, on-prem, different dependencies, the backend is throttling your API and so forth. So basically you are running a long-run process, not necessarily consuming CPU, but it takes several minutes or hours or days to complete, with different states in between and so forth. Think of it like a business process.
Yeah.
So you can either use Azure Logic Apps in combination of functions or just functions to basically describe what you just mentioned. You basically fire up an event, starting a process. When that process completes on a completely different subsystem, either call back with a webhook or drop a message on a queue or whatever you want to basically trigger the next step or the next function to complete the process.
So you brought up Logic Apps, and now there may be another question mark over our listener's head, because the functions and Logic Apps work together. It's not an either or thing. Whereas Azure Functions are code that's triggered by an event. A Logic App is a workflow that may call different functions, and then when those exit based on the result, then another thing happens, or the whole workflow brings the whole workflow idea, to a bit of a business process to services. Correct.
Basically, Logic Apps are super great. As you said, you can look at them as a managed workflow for you, a workflow engine. They do a lot more. They do a lot more in terms of integration. They have connectors that can bind into 100 and plus, SaaS services, both Azure services, Office services, and a lot more like whatever, SAP, Salesforce, Box, you name it, basically.
Yeah.
A lot of those services. So that's huge in terms of the integration, and you can combine those with a function, right? You can get a trigger from Twilio and drop it into a function, do something, return it back to the workflow, to the Logic App, and so forth. So basically they are really better together story. They're super powerful on its own. Combined, they're have mythical powers, because it allows you to. Logic App is also serverless by nature.
Right.
It's event-based programming model. You can program it. You can express your logic. It scales to handle anything for you. It's provide you a sub or micro kind of billing, basically event-based billing, whatever you want to call this, but you're not paying for VM forever. You're just paying for the actual processing or work that you're doing. So it's serverless by all definition. And truly combined together, it gives you the ability to connect, do a lot of those hassle things. Like, think about it. You want to listen to Twitter today.
Yeah.
What do? Right? Let's say you don't have serverless. You're just regular web API. You just want to build an app. So you need to build this cron thingy that runs every minute or whatever, right? Web jobs or any other means. Go to Twitter. You need to auth. You need to do all the auth song and dance. You need to securely find a way to put those credentials in a way that you can deploy it over time and yada yada. Use the Twitter SDK to download all the data, and then you can start doing your business logic.
Yeah.
With Logic App, it's a single connector that does everything for you. Serverless, just deploy there. Whenever there's a tweet you want to listen, it basically calls the functions or calls the next process in the workflow, and you're done.
Yeah.
So you're not setting anything. Like the whole setup time, the whole understanding of how to work and tap dance around all those dependencies is simply eliminated for you. So we like to say, like, you can write code, you can write business value from the first line of code, whether you're using Logic App or functions.
Awesome.
When it comes to deployment, I now have another chunk of code living in another place. So how do I make sure I coordinate the package that is all the different pieces of my application?
Another good question. And basically, Azure Functions, Logic Apps, Azure Function apps and Logic Apps are basically an Azure resource.
Right.
As part of the Azure Resource Management. So we have ARM. So there's a way to with a JSON file basically describes all the resources, all the dependencies. Logic App code is actually JSON. How do you basically describe or define your model? All of this can be bundled with an Azure Resource Manager package, and that package can include the function app, which can point to like a Git repository, so we can do the automatic integration. So as soon as you create a function app, we can deploy the code. All the dependencies that comes with a function app, which is basically just storage, but you can add, SQL, DocDB, Event Hub, whatever you need, basically. Azure Resource Manager will allow you to create a full package, which includes all the dependencies for your solution, combining them together, putting all the proper keys and connection strings, whatever you need to have them, and basically create. There's work there, don't get me wrong, and Visual Studio will offer you great tooling for that, but there's still work. Once you're done, you can easily deploy this multiple times, repeatedly, across multiple region, resource group, whatever you want.
So are there any limitations? I mean, with the API right now, something that people expect that might not be there or might not be ready or not quite what people expect?
So I would rephrase the question as it's not necessarily a limitation. It's more of when you talk about serverless, whether implicit or explicit, you are talking about async programming model event-based distributed applications.
Yeah.
People need to understand that or have that leap or whatever you want to call it, right?
This is an architecture you're talking about. This is not just a chunk of code.
Correct. You need to understand, and basically the way we present serverless as a whole is like, hey, we take care of management and everything is happening magically for you. The questions of how you scale your app basically becomes a question of, hey, how do I architect my app to become serverless?
Yeah.
And the best example that I have, the canonical example that I bring, and I can happily say it because it's an internal customer and not an external one. We had an internal Microsoft customer comes in and basically sends us an email saying, hey, your technology is garbage, it doesn't work, it doesn't scale, it's all a shame, it's a fake, yada yada yada.
Okay.
And we say, okay.
So loving is what you're saying.
I mean, fair, good feedback. Thank you for the constructive feedback, which really helped. Appreciate it. But do you want to meet and we can talk about it a little bit? So we met with the team, and basically what they did is exactly what we would imagine they would do. They had not a web job, but they have an executable runs as a service, a daemon, right? A cron job. Ran as a Windows service on a VM. And every whatever number of minutes or hours, whatever you want to call it, goes to a data source, gets basically a big chunk of data and go for each line item. And usually it was about, 10,000, 20,000, 100,000. They even got to the point where they need to process millions.
Right.
In a loop.
In a loop. Yeah. Now, when you run for each on threaded, on .NET, on a server, on a beefy server, it scales pretty nice. I mean, the .NET will take care of a lot of that for you. Yeah. When you do it on a poor little functions that runs on a single server, because if you think about it, in terms of the system had a trigger timer for that perspective. The function does whatever the function do. System doesn't realize there is tons of work to be done because nobody told it. There was a single trigger, a single function invocation, and now that poor single function invocation that runs on a single instance, and usually not a really powerful one, needs to handle all of that load.
Yeah.
And the very, very simple solution for this kind of problem is basically instead of calling the method that goes and implement or do the business logic, what we do is basically parallelize that. We just talked about it, right, a couple of minutes ago.
Sure.
Because each of those tasks are independent completely and stateless and idempotent as we like it. So basically you in-queue a message with the work to be done, and now you all of a sudden have a queue in which the system can monitor and scale accordingly to adopt and handle the load. So if you have 1,000 or 10 of thousands or 1 million, I don't care, because the system will be able to allocate enough resources and basically spread the love across many, many different servers, and each one of them will run a small chunk of the work, but it will scale like crazy.
Right.
We have customers running on running their functions on literally hundreds of instances at the same time. So they were able to cut, once we did it, they will be able to cut their processing time from the original solution of multiple hours to, 15, 20 minutes.
I think that problem that you just described there has been really a problem with typical desktop developers who are now sort of getting into the online world and the remote data world, however they're doing it, whether, it's even with ASP and ASP.NET. Going all the way back there, we had this problem. I mean, you used to have full control over everything, a single CPU. You have a chunk of data that you got from your server, maybe running on a server. You iterate through it, and that's the way it works. But, I mean, we've been seeing this problem since the beginning of .NET, since the beginning of services, really, that, we think we can just go through a loop and, a million rows later, we spit out a report. And it just doesn't happen that way. It doesn't work anymore.
It definitely doesn't work in big data and the volume of data and services and information we have. And so to iterate on that, basically the bottom line is when you go and do functional programming or using serverless is too big of a word, but when you look at functional programming, events-based programming, you need to just understand that every function needs to ideally be stateless. Every function should complete as soon as possible, as fast as you can. Every function should, you should try to do one thing in that function. If you have you have multiple methods that you're calling in and out and stuff like that, think of how you want to break this apart. And unfortunately, this breaking part today, it's not natural. It's not easy because if I need to put a method in a queue and call another function, I'm doing it right now because it's become second nature. Yeah. People are coming, off the street regular with, a different state of mind, or their regular programming patterns doesn't follow that. It's unnatural for them. It's not easy, and that's the current leap of faith that we need to make here.
Well, that's great. We're going to obviously link to some resources that you've shared with us, and people can get busy right away with Azure Functions. What's next on your list of things to do, Yochay? Yeah,
so there is a lot of Azure. Most of my time these days is spent on Azure Functions, and we obviously drive the team. So we have some cool features coming down the pipe that we can't broadly talk about yet.
Okay.
But we iterate very fast, so I hope within couple of weeks, maybe 2-3 months from today, we'll have most of those features out, which include fabulous feature for monitoring, deployment, and also we have something that will try. We hope it will help address specifically the last problem we talked about how you separate and build this programming model serverless style in terms of functions and calling other functions and all those dependencies. So it's pretty exciting. We're doing a lot of work, a lot of customers, and I think Azure Function and serverless in a whole, it's going to be a major disruptive force in cloud computing in the next 2, 3, 5 years, and we're very happy to be working on it.
Is there any particular blog that we should be looking at to keep up to date on what's coming down the pike?
Yeah, so there is the App Service blog on MSDN. Again, you guys can see the link as part of the resources. There is a few Twitter handles you want to follow. There is the Azure Functions, at Azure Functions Twitter, which is the team one, and then there are a few individuals like myself, Chris, Anderson, Donna, Mallory, and David Ebo. I'll kind of includes all of them in all the proper handles you want to follow, where it's the individual folks on top of the Azure Function team.
Great. Sounds good. Yochay, thanks very much for spending this hour with us. It's great stuff.
Thank you for having me. It was an awesome talk.
You bet. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and, of course, in the cloud. online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.